Okay, let's give this a try. This is part 2 of how to factor quadratic expressions. And I'd like to remind you that quadratics are second-degree polynomials. That's all they are. Okay, so this is part 2. So this is the part where I am going to demonstrate two particular methods for factoring trinomials in particular, because we know that if a second degree polynomial, a quadratic, is a monomial, you don't have to factor it at all. You just have to solve it. If you have a binomial, you know that you can very easily find a GCF, right? Greatest common factor. What would the greatest common factor of this binomial be? Well, it would be x, right? Because this term has an x and this term has an x, okay? But how do you factor a trinomial? When you know, because we've been multiplying them, that a trinomial is made of two binomials, and you don't know what those two numbers that have to go with the x's. So let's use multiplication to demonstrate what we're looking for when factoring a quadratic trinomial. So here are a pair of binomials that we can very easily multiply, right? X times x, we know that's going to be x squared. X times 2, we know is going to be 2x. 3 times x, we know is going to be 3x. And 3 times 2 is going to be 6. So the structure of how to multiply is what is going to help you remember how to factor. Please note, these two terms right here are going to be combined. They're like terms, right? I'm going to add them together and I will get plus 5x, right? But when I found this term, my constant term, I multiplied 3 times 2. So this is the key to what you're thinking of when you start to factor, okay? When you factor, you are looking for terms that multiply to C and add up to B. Now you might be asking yourself, Mrs. Heinzman, what are you talking about? Well, this is what I'm talking about. Please recall, I told you when we began the polynomials unit that you would want to pay attention to this structure right here, standard form of a quadratic or second degree polynomial. All right, this A coefficient always associated with the squared term. This B coefficient always associated with the linear term. And this C coefficient always a constant. Always, always, always. So when we factor a trinomial, we are looking for two numbers that multiply to C right? Multiply to C and add to b. And you can see this, right? I mean, it's obvious. I multiplied x times 2, I got 2x. I multiplied 3 times x, I got 3x. Well, now I have x's that I need to combine, and I get 5x, right? 2 plus 3 is 5. When I found my c term, I had to multiply 3 times 2. So if I wanted to break this quadratic apart, I need to look for factors of c that add up to b. So let's talk about and put that into an actual procedure. Okay, so the first way that I'm going to teach you is called the Berry method. And this Berry method is named for the teacher who made it popular. I can't say they were the teacher who invented it because I highly doubt that that's true. But it's called the Berry method, and it works for any quadratic trinomial that can be factored. So let's see how to do it. Now I've got the procedure for the Berry method written over here on the right. It's basically 3 steps. Step number 1, put down 2 sets of parentheses right next to each other. Watch what I'm doing. Okay. Second, you multiply A times C. Okay. Sometimes A is just going to be 1. Sometimes A will be another number. All right. In this case, A is 1. So I'm going to multiply 6 times 1. And that, of course, equals 6. So let's go to step 2. Well, I already did step 2. Now we go to step 3. So now we list all of the factors of A, of C times A, or A times C, all right? In this case, I'm looking for the factors of 6. Well, let's see. We have 1 times 6, we have 2 times 3, and that's about it. In particular, I'm looking for the pair of factors that add up to B. Well, looks like I found them, 2 and 3. All right? It doesn't matter where you put the 2 and where you put the 3. So now let's finish. So how do you determine what sign these are? Well, you look at first you look at the sign that goes with your C term. If it's plus, then you know that both of your signs in your binomials either have to be both negative or both positive, right? So then you look here. If this sign is positive, then if C is positive, then you know that both of your binomials for B have to be positive. Last, you go ahead and write your A term. Okay, only you don't write the squared, you just write, in this case, I don't have another number other than 1, so I'm not going to write 1. So now I'm done. Okay, there's an extra step that you do when A is greater than 1, but we'll learn about that in a bit. This is enough for now, and we're going to practice a couple of these. So you can check yourself. I invite you to check yourself. Okay, x times x, x squared. x times 3, 3x. 2 times x, 2x. 2 times 3, 6. Combine like terms, and I have x squared plus 5x plus 6, which is what I started with. So you know that you did it correctly. See you in the next video, and I'll show you the box method.